Hello class. Today we're going to be talking about substitution. Substitution means to take something and replace it with something else. Like when your teacher's gone, you get a substitute in the place of your teacher. Now in math or in algebra, which is a kind of math, substitution means putting numbers where the letters are. For example, when we have x minus 2, but we've been told that x equals 6, we can then substitute the 6 for the x because they just told us that x and 6 are the same thing. They are equal. That means that we can trade them in the equation. So I'm going to use my highlighter. And I'm going to do this. I'm going to say that x right here is the same thing as this 6 right here because they told us that they were the same thing. Now, once you know that this is 6, then you can solve it. 6 minus 2 is 4. Voila! Substitution is very, very simple. You just need to find out what that variable, what the letter is, and then trade. Take the letter out and put the variable in. Okay? So right here, when we have x is equal to 2 in our first example, we want to know what is 10 divided by x plus 4. So to do this, it's very, very simple. If x is 2, that means I'm going to rewrite the problem, but instead of writing x, I'm going to put 2 right there. Let me show you why. We got 10 divided by, now instead of x, I'm going to put 2 right there, and plus 4. Voila! I've done my substitution correctly. Now sometimes when you put a number in substitution, people like to use parentheses to show that this is where x used to be and bring the whole number in. I like to do that when I have negatives, and we'll talk about that later, but you don't need to, but you can. Okay, let's move on. Now that I have this problem right here, in order to solve, I need to use order of operations to solve it. Go ahead, go. So we had division, which I should do first. 10 divided by 2 was 5. If I bring down the add 4 to that, 5 plus 4 is 9. Voila! So I substituted, and this expression right here is equal to 9. Let's try the next example. In this one, x is equal to 5. Notice how sometimes in this problem, x was 2, but in this problem, x is 5. That's because these letters are variables. In different problems, they're going to represent different numbers. Okay, so let's go ahead and substitute here. X plus x divided by 2. So instead of x, I'm going to write the number 5, because it's 5, plus. Now you notice how there's another x? There's 2 of them in the same problem. That means that they are both 5. All right, so now I have it all filled in. 5 plus 5 divided by 2. Now we just need to solve using order of operations. Go! Okay, so in this problem, we had to do the division first. So we did end up with a decimal. 5 divided by 2 is 2.5. When we add that to 5, our answer should be 7.5. All right, let's do one more example before we bring in the negatives. In this example, we have 2 variables. The x's are going to be replaced with 3's, and the y's are going to be replaced with 4's. This happens sometimes where you have more than one variable. So we're going to replace this x right here with 3. So this is 3, and don't forget that it was squared, so we're going to put a squared right there, plus, oh, looks like we have another 3, and y of 4. Ugh, wait a minute. These are right next to each other. So is it 34? No, that would be weird. Let's think of this as if we had used the parentheses to input our numbers. Do you remember what operation we do when we have no sign in between them? That's right, we're going to use multiplication. See how in between x and y, there was no sign. There was no addition, there was no subtraction, there was no multiplication, and no division. So our default right there, yes, write this down. Our default is always to multiply when they are right next to each other. You will see this a lot, especially as we're dealing with algebra and letters. This will happen. So when you fill in your x's and y's, it's not 34. It's 3 times 4. Okay, now that we've got it set up, go ahead and solve. Okay, so I did my exponents. 3 squared is 9. Multiplied these together. 3 times 4 is 12. Added those together, and I got 21. Awesome. So substitution is good, and you learned our trick for when this happens. So let's look at what happens when we use negatives. When using negative numbers, always put parentheses around them so that you can get the calculations right. Ooh, that rule sounds important. So I'm going to put the word always right there. And I'm going to highlight it just to make sure that we do this well. When substituting numbers, always put parentheses around them. Okay, so let's take a look at our example and see them use the parentheses to help make sure we get it correctly. In this situation, x is going to be a negative number. It's -2. Okay, so every time we see x, we're going to input parentheses -2. Okay, this is going to help us make sure that we're doing our math correctly. Okay, so 1 minus x. See how the x right there is -2? Okay, next we would plus x squared. Now, I have this x right here, this -2, in parentheses. And that's important when you're dealing with squares. So, what's going to happen is 1, the double negative turned into a plus, and then you're like, wait a minute, why is -2 squared 4? This is a very special situation, and we're going to use this space off to the side to write it down. There is a difference between when you square a -2 and when you have a negative off to the side of a 2 squared. And the difference is whether or not that negative is included in the squaring. For example, this one right here, just like we saw in our problem, means we're going to have -2 times -2. Well, we all know that a negative times a negative is going to give us a positive answer. So that works in the case of the parentheses. When we don't have parentheses, however, that negative is not being squared. So this, we would do 2 times 2 is 4 and bring down the negative. Those are very different situations and end up in opposite answers. So that is why it is crucial when you are substituting negative numbers to use the parentheses so that you know which situation this is. Okay, so now that we've talked about that, let's take a look at our first example. In this example, z is going to be -3. So we're going to input 3 right here, and I am using the parentheses, squared, Now it says minus right there. And another z. Oh, I better use parentheses again when I put that in here. And minus 1. Okay, so now everything is filled in, and we're going to use order of operations to solve. I'm going to use my exponents first. Negative 3 times negative 3 is going to give me a positive 9 because we're using the Math Man rules. Then I'm going to change this minus negative to a big old plus sign and bring down the minus 1. Okay, so I've taken care of my exponents. Now I can just add and subtract from left to right. 9 plus 3 is 12. Minus 1 is 11. Ta-da! We're doing it! Wonderful! All right, let's try this next one. In this situation, y is equal to negative 5. Now go ahead and substitute and solve, and then we'll come back and check your answer. Go! Okay, hopefully you were able to input the negative 5s. Now I want you to notice, in between the 3 and the y, there's no sign there. And just like that, we have this parentheses here with no sign. That means we are going to be multiplying there. Same thing here. We've got two numbers with no sign in between them. Remember that negative is part of in here. Two numbers, nothing in between. We're going to multiply. So, let's take care of good old PEMDAS. We're going to take negative 5 and square it first. Exponents come first. Well, after the parentheses. So, negative 5 times negative 5 is a positive 25. I'll bring that down. Now, I still have to multiply it by 3. I'm bringing the rest of the problem down to keep my notes nice and organized. Now I'm ready to multiply. Got my calculator here to help me because I don't have my 25s memorized. 3 times 25 is 75. Now I'm going to do 7 times a negative 5. I already know my answer is going to be negative. And 7 times 5 is 35. And I need to minus 4. Okay, we've done exponents. We've done multiplication. Now we're ready to add and subtract from left to right. 75. Different signs subtract. So I get 40. Then I minus 4. And I end up with 36. Voila. All right, we have one more problem to try. You go ahead and put the substitutions in, and then we'll check your answer. Go! Okay, so I have it substituted. A was 6 minus negative 2. So that's 6 plus 2 over 6 and a negative 2, which is 8 over 4, which reduces to 2. Good job!